Good morning to one and all present here. Today we are going to see in data mining and data warehousing the block 4, that is about the classification and prediction, and what are the different categories of classifications we have, and the methods, various methods, and also how I can evaluate the accuracy of the classifier or the predictor, and what is mean by ensemble methods and model class selection. So we're going to see all this. So let us see first what is mean by classification. So what is mean by classification? Say, take an example of a bucket full of balls of different colors. So when you want to when you want to segregate them, how will you segregate? You have an attribute called as the color. Based on the color, you will be segregating them into different categories. So this is what we call it as a classification. So classification is the data mining methodology, which is going to categorize based on the classes. And we have to predict this while we training the classification classification algorithm with some set of data, and I'll be giving a test data. The classifier has to classify it correctly based on the knowledge that it has gained from the training data. So this and the prediction of that particular classification accuracy should be high. Accuracy should be high. So this is what the main objective we have. And when I go for the data analysis, there are two forms of data analysis. For that, this one is called as the classification, and one more is called as the prediction. Say, for example, when I go for a bank, in a bank, if I just approach for a loan, whether it is safe or risky, you're going to classify the particular customer. When I provide, like, can I provide loan? Is it risky or it is safe? So classifying that, segregating that two categories is called as the classification. And prediction is nothing but based on his income and based on his uh, details that he has provided regarding his occupation and regarding his payment, salary slip, all those things, depending on the properties he's having, or based on that, I can predict whether he is be able to pay the bank loan back. So whether he is able to have that expenditure to be supported by him. So whether he is able to repay it. So I can predict that. So that is called as the prediction. So I think you will be clear with us now. So you'll be going to classify, and classification based on the categorization, and prediction is nothing but based on certain data, we are going to predict whether it is able to perform it or not. Okay, so this is what is called as the classification and prediction. So we are going to again see in detail about the classification. So the first, I just told you there are two categories of data analysis tasks. So the first one is called as the classification. So what, again, I've taken an example of a bank person. So bank loan officer want to analyze whether the data in that is whether he is able to pay it or not. And when another example, if you just take a marketing person, marketing manager, should analyze whether a person, a customer who will like whether a person, whether a customer will buy a particular product. Say, for example, let it be a computer or let it be some other product. So whether he will be able to buy it or not, that is being given by this particular classification. So whether he will be able to perform it or not, so that is being given by this particular classification algorithm. Fine. So we are having these two algorithms where it is classifying whether it is safe or risky, or whether he'll be buying or not. Okay. So these are the two examples we have with the classification. So when I go for building a model, so there are different steps we have. So the first one is called as the learning phase. So what is mean by learning phase? As I already told you, we are going to predict, we are going to train the algorithm, or train the classifier algorithm with a certain set of data. Say, when we take a real time example, I'm going to have like I'll be making the robot or say a small baby. You just take a real time example itself. So I'm just going to take a small baby. So we will be teaching, or we will be make her or him to understand certain alphabets of say the language English. So we will be training the kid with certain set of words and make them to understand the what are the characters or what are the alphabets we have and what is the meaning of it. So I'm going to tell them that certain things. Then when I give a new word or a new mm, a word in an English language, the kid has to be able to understand what it is, what are the alphabets in it, he by himself or by herself. So this is what is called as the thing. So that this first phase, he or she will be learning, and the next in the from the next phase, we will be when I give a data, it has to be there is a test data. It has to understand. It has to uh, do that. It has to classify that based on the learning what it has done. So this is what is that. Okay. So we'll be having a training set with set of data uh, records, and based on that data it will be just going for doing. And this training data, it's called as also called as the sample data. Okay, so as I told you, this is how it has been done. So I'm having they say for example a set of data here for a bank thing. So I'm having the name of the customer, then the age and his income and the decision. So I'm having a training data. What I'm having, if he is young and he is having a low income, it is risky for. So I told you, the decision can be either it is safe or risky. So it will be safe if I'm going to have it as high, middle-aged and high income. So if I have a middle-aged person and he's having a higher income, it is safe. And also a senior member with a even with a low income, it is safe because he or she will be having some responsibilities to repay the loan. So certain things we will be having certain rules here. So this based on the rule, it will be predicting or it will be classifying whether it is safe or uh, risky. Okay, so this has been done. So we'll be having here, I'm having a set of training data. So this training data is fed into the classification algorithm. We'll see what are all the classification algorithms we have. So this will be given, the data will be given, training data will be given to the classification algorithm. And based on the classification rule, this particular classification algorithm is going to classify. So what is the classification rule for this particular example? Say, for example, if the age is youth, if there is a young person, then the decision is risky. So irrespective of whether he is having a low income or high income, it is, if he is young, it will be risky for to provide the loan. And if he is going to have a middle-aged person, if the youth, if the person is young, but his salary is going to be high, then he can be given, like he can be given the, whereas he can give the loan, you can classify that he is safe. The decision is safe. And when I go for a middle-aged person and the income is low, then again I'll take that as a risky thing because he'll be thing. So this is how it has been given. So based on this particular classification rule, so when I go for a high a senior person, if he is having a low income, again, whenever you go for an income which is low, irrespective of age, whether he is young or middle-aged or senior, if the income is low, and you'll be feeling that it is going to be risky. But when I go for a middle-aged person and with a low income, you will be feeling that it is going to be a risk one. So if I have this criteria, then I'll be able to Based on this classification rule, I'm going to classify whether it is risky or it is going to be safe. So after this one, after classifying the data, training the data in the learning phase, we are going to go for the next phase where I'm going to classify the actual classification is going to happen. So using the test data. So this test data is used to perform the classification, and whether it is classifying it correctly or not with the learning phase, it is measured using a metric called as accuracy. So you'll be having here the same set of training data I'm given some training data, but now I'm going for giving a different set of test data. Say John is a person who is middle-aged and he is having low income. As I already told you, the decision rule or classification rule, what it is having, irrespective of his age, if he is having a low income, he will be not feeling safe. Only for the senior member, the senior age, if he is having a low income, it is safe. Other than that, if for a middle-aged person and a young person, according to our training data, it is a risk to provide the loan. So when I give this test data, what is this test data? It is going to have a person who is middle-aged and he is having a low income. So what should be the decision? It should be having a decision classification as it is risky to provide the loan. So providing this, whether it is providing that it is risky or not, that is measured as the accuracy. So the model which is providing a higher accuracy will be treated as one which is the optimal solution. So we'll be also seeing some of the steps activities that we will be doing in the classification and prediction. So for a classification and prediction, as I mentioned you, either it can be a training data or it can be a test data. It has to be first prepared. So I'll be having a huge amount of data. So taking data relevant to my problem, it is the major thing. So that is what you call it as a preparing the data. So there are so many activities going to happen with this preparing the data. So the first one is called as the first activity is called as data cleaning. What is data cleaning? You are going to remove the unwanted data. Noise means the data which is irrelevant to us and the data which is not relevant to the current situation. Say, for example, when I take the bank loan, then the bank loan, if I have certain things like the address of the customer or say his what are all the properties, that is relevant data. So what are all the movable and immovable properties he's having, that is called as a relevant data. Say his age, that is a relevant data. His mobile number, it is not going to be relevant for this classification. If he is having a particular mobile number or not, or something like that, it is not going to be deciding, it is not going to be make use of in the classification. So I can remove all those, say, for example, the mobile number, the address. So all these data I can remove from the father name, mother name. So if I have these data, it is irrelevant to the current situation, current problem, because I'm going to predict, I'm going to classify whether the loan approval is risky or safe. So there is no relation, no thing that is you're going to have it with whether the person is having a father name like some X or Y. It is no way related to your approval of the loan or not. Whether the person is having this particular phone number, it is not going to have any relevance with your loan approval. But when I go for some certain fields like his age, his income and the occupation, then his movable properties, his immovable properties. So these all will be relevant to the data, relevant to the home loan approval. So that and all will come under this data cleaning. Okay. Now we have the next one. The next activity we are going to do is the relevance analysis. What is mean by relevance analysis? As I already mentioned to you, certain attributes is nothing but the fields. So we'll be having certain attributes which is irrelevant. So we are going to find the correlation, that is whether two attributes are going to be related in what way. So if they are not related, if they are not having any relevance, I can just remove it off. And then data transformation and reduction. What is mean by data transformation and reduction? So data transformation is nothing but you're going to make it into another format. You're going to convert it into another format which is understandable. So that is called as the data uh, transformation. And then you are going to have the reduction. Reduction is nothing but you're going to reduce, say, I just told you, no, data cleaning. So you're going to remove some data, so like that. So the data transformation again is going to have two methods. One is called as normalization and one more is called as the generalization. What is mean by normalization? A data that is transformed will be, you will be having that it will range. So it will be either it will be in a, fall in a within a small specified range. So normalization involves scaling all values for a given attribute in order to make them fall within a small specified range. That is called as the normalization. So normalization is used if when the learning step, the neural networks or the other methods involved measurements are uh, used. So in that time, that's the normalization will be used. And then the generalizations we have. The generalization will be mainly helpful for transforming the generalizing it into a higher concept, say for the purpose of concepts hierarchies. So we are going to use this generalization in the concept hierarchies. Okay, so we're going to have it. So we are going to have a comparison of the classification and the prediction. So we are going to first check out with this uh, decision tree. So a decision tree will be one which is going to be useful for this classification. So that is one thing. So a decision tree, I'll just show you the structure of it. So it like this, it will call it as the root. This is called as the root, and these are all called as the inner nodes. And this is called as the all the things which are in a circle node. Those are all called as the leaf nodes. So you'll be having this as a leaf node, and this is all called as the inner nodes, and this is called as the root. Okay, so the top one is called as the root. So as I told you, a decision tree is a tree-like structure which includes the root node, the branches, and the leaf nodes. Leaf nodes is nothing but the last node, which doesn't have any child. That is called as the leaf node. So, and all the internal nodes denotes the test or on an attribute. So each branch denotes the outcome of the test. That is what it is being given. See here. So age is a, whether it is age, he is a student, or whether he see whether he'll be having the like whether he what is the annual income. So which when it is very high, then you can have it as yes. When it is fair, you are not going to provide the loan. So the same example we have taken. And if it's a student, irrespective of him having the, you're not going to consider the income of him. We're going to say if he's a student, and then if I'm having he's a young student, no, then you'll go telling that it is no. So if he's a young person and he's not a student, then you'll not give the loan for him. And if he is a young person, and he is a student, then I'll be providing yes. Then I'll be providing the loan. And as a middle-aged person, irrespective of his irrespective of his income, I'll provide him the loan. And the senior person, if he is having a fair income, as a low income, then you'll be having no. You'll not be giving the loan up for approval for him. If he is having an excellent salary thing, you'll be having the loan approval for him. So this is how I'm going to have the decision tree. So a decision, each internal node denotes the test on the attribute. Each the branch denotes the outcome of the test, and also each leaf node holds a class label. The topmost node is called as the root node, as I already told you. Okay. So the benefits of having this one, it is going to does not require any domain knowledge. What so by the using of the decision tree, we can easily understand. So if I'm going to have a bank this one classification, I need not know in what is like in-depth knowledge of how the approval will happen, how the what are all the different rules and constraints we have to consider. So we need not have in-depth knowledge of domain, the particular thing what we are going to work on it, and it is easy to understand. That is what is be given as easy to comprehend, and also it is very simple and fast. So these are the benefits I'm having with the decision tree. So we are going to see the next about the decision tree induction algorithm. So the decision tree induction algorithm, it has been named after the person called as J. Rose. In 1980, he developed this induction tree algorithm, as it has been called as ID3. So this he presented C 4.5, which is the successor of ID3, and ID3 and C 4.5 adopt the greedy approach, and there is no backtracking. Backtracking means you cannot traverse back. So you it's like a process. Like if I go for some improvement, I can just say, for example, I will be learning and I'll be writing a test. If I'm not giving, I'm attending a test, and based on my performance, if I'm going to have a better performance, I can proceed. If not, I'll repeat again learning. So that is called as the backtracking. Say when we going for any aptitude or test or something like that, we cannot have backtracking. Say if I'm not performing well in the particular test of an aptitude or for a company, then I cannot again learn again and do it. But when I go for some things like when I take a simple example of this NPTEL course, I'm going to write the assignments. So every week they will be providing the assignments. So that assignment, when if I just perform it after the test, if I feel that I'm not performed, I will not get the score back. But still, I'll not. If I feel that I'm not performed the assignment properly, again I can go for till the last date. I can just again apply, learn the materials whatever I'm having. Again, I can attempt the assignment. So this is what it's called as the backtracking. And this decision tree, it is going to have a partition of data, which is going to have some set of data and associated rule in it. And based on this attribute, based on the selection rule, classification rule, it will be splitting the class things into different classes. So there can be any number of class. So that is will be getting the splitting. Okay, so that is what is being given in this methodology, in this algorithm also. So I'll take if a tuple is nothing but the records, and I'll be taking in that. And then if all are of the same class, then I'll have that as the that particular thing, that particular classification. If not, I'll go for having a different leaf node, which is going to be having the different uh, uh, result of that particular classification. So based on that, I'll be making the decision tree. Okay, so that is what it is being given in this particular example. So I'm going to have the decision tree. So if this is called as the DJ, so the DJ be the set of data tuples in D. So D is nothing but the entire data record. So I'll be going to have that set of data. So that will be taken. And then if DJ is empty, then I attach a leaf node with the majority class in D to node N. Else, if I'm not having the DJ as empty, then I'll attach the node returned by generating decision tree to the node N. So this is how it is going to do, and it is going to return the N value. So next we'll see about data pruning. So what is mean by data pruning? It's nothing but it is performed in order to remove anomalies in the class training data due to noise or outliers. So outlier means say I'm having a set of values. So having all the set of marks. So if I'm immediately like in the middle, I'm just having some data. All the ranges of data will be from say 90, 0 to 100. 99, 100. Then if I'm having a mark which is 120 or -5, then that is called as the outlier. So I'm going to remove these things. So that is called as the data pruning process. So data pruning approach has two types of things. Pre-pruning, that is before the construction of the tree, I'm going to do it, remove it. It is called as pre-pruning. And after the creation of the particular decision tree, I'm going to prune it. It is called as the post pruning. So we are going to see the next concept. It is called as the, so we have seen now what is mean by classification, how it is being done, and what are all the activities we perform before the classification or the prediction. So we were seeing about the data removal, the noise cleaning, data cleaning, and then we are going to find out what is the relativity of those data. And we also saw that we are going to have some data transformation. So we saw all those things. And also we saw how to use a decision tree to represent the classification. So if we are going to represent that, we're seeing that. We have seen that one. So now we will see about the Bayesian classification approach. So this is based on the Bayes theorem. So Bayesian classification is based on the Bayes theorem, and it is a statistical classifier. So, and also it is going to predict the class membership as whether it is such as the probability that the given tuple belongs to a particular class. So this is how I am going to have the Bayesian algorithm. So the Bayes theorem is named after the Thomas Bayes. He is the one who has given that Bayes theorem, and it has been having two types of probabilities. One is called as the posterior probability, and one is called as the prior probability, which is posterior probability is being represented by P H of X, and prior probability is being given by P of H, where X represents the data tuple and H is some hypothesis. So according to the Bayes theorem, PH of X is equal to P of X slash H, P of H slash P of X. So this is what is called as the Bayes theorem. So Bayes belief networks specify the joint conditional probability distribution. They're also known as belief networks, Bayesian networks, and probability networks. And a belief network allows class conditional independence to be identified between the subsets of the variables. So we are going to provide the graphical model of causal relationship on which the learning can be performed. It is training, use the trained Bayesian network for classification. So this is what going to use. It is going to use the Bayesian belief network is going to use the trained Bayesian network for classification. And there are two components that define Bayesian belief network or directed acyclic graph. This is the first component. So the directed acyclic graph in here, we are going to have each node in a sorry. So we have the two components that define the Bayesian belief network. That is the first one is called as the directed acyclic graph. So in the directed acyclic graph, each node in the directed acyclic graph represents a random variable. And this variable can be a discrete or a continuous value. And it also has some correspondence to the actual attribute of the given data. So the representation we can see here. So whether I'm having a family history, so based on the family history, whether he is going to will be having whether he's having a lung cancer or not. So based on the whether he is going to have, he's a chain smoker or not. Based on that, he can be having a lung cancer, or he can have emphysema, 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 and it can have, there is the lung cancer can have the lung cancer can be predicted using the positive X-ray. So based on the X-ray result, I can predict it, or I can go if he's going to have using the variables. These are the variables I'm having. This the family history, then the smoker, whether he's a smoker or not, then the lung cancer, and then positive X-ray, and then the emphysema, and then the um, dyspnea. So based on these things, I can go for having the prediction happening. So for example, a lung cancer is influenced by a person's family history of lung cancer, as well as whether he is a person or whether he is a smoker or not. It is worth noting that the variable positive X-ray is independent of whether the patient has a family history of lung cancer or that the patient is a smoker, given that we have the patient has lung cancer. So this is what we have this one. And next we'll be seeing about the conditional probability table. So the conditional probability table for the views of the variable lung cancer, showing each possible combinations of the variable values of its parent nodes. There is the family history, the smoker as for it is given as follows. So you'll be having whether he's having a whether he's what is the family history, and then whether he is a smoker. So the prediction, the probability of having lung cancer. So whether if he is having a family history and he is a smoker, the probability of lung cancer is 0.8, and the probability of not having lung cancer is 0.2. And whether he is having a family history and he is not a smoker, then he is going to have the probability of having a cancer as 0.5 and not having the cancer as 0.5. And if he's not having a family history, but he's a main smoker, then you're going to have the probability as 0.7 and the probability of not having the lung cancer as 0.3. When I go for having here, so here I'm having, he's not having a family history and he's not a smoker. So it has to be represented as minus yes. So he's not a first main smoker. The probability of having a lung cancer is only 0.1. So this is the probability table, which gives you based on the conditions. So based on the variables, here we have 3 variables: family history, smoker, and then lung cancer. So if he is having family history and he's a smoker, I'm going to have some probability. So when I go for the probability here, when you sum up of all these column values, you'll get it as 1. So this is what I'm going to have it as the classification using the Bayes theorem. Now, next we will see about the prediction methods. What does mean by prediction? As I already mentioned to you, the prediction is nothing but I'm going to have the prediction whether based on a certain variable, I'm going to predict whether it is going to be value, like whether it is safe. Like, so when I'm going for classification of bank loan, I'm giving that whether he's safe to provide the loan or not based on his income and something. So whether based on the condition of his income and his background, like his salary background, I can have a prediction that he'll be paying it or not. He'll be correctly paying it or not. That is called as the prediction. So whether it is, will he be able to manage in the future after 5 years or 6 years, if he is able to continue his payment. So predicting the future is called as the prediction. So Excel miner is one which supports all facets of data mining process, including data partitioning, classification, prediction, and association. So we are going to have this data partitioning. So data partitioning is dividing into categories, classification, different classes, classifying into different classes, predicting, and also association. Association, grouping it, all them. And the third stage of the prediction, third stage is a prediction is used to predict the response variable value on a predictor value. So we're going to find out based on a particular input, particular predictor variable, I'm going to find out whether it is going to make it or not. So that is called as the response variable. So Excel minor functionality feature four different prediction methodologies. That is called as the linear regression, K nearest neighborhood, regression tree, and neural network. So we'll see one by one. Each method has its own features. So we'll see one by one. So how to access this prediction methods in Excel? So you are going to launch the Excel, go to the Excel, in the toolbar, you will be having something called as the Excel Miner platform. So go there, and in the data mining section in the Excel platform toolbar ribbon, you'll be having something called as data mining section. Go there and give predict. So you'll be giving the you get a drop down menu. In the drop down menu, you'll be having some different prediction methods selected. So you saw here now the different prediction methods like linear regression, K nearest neighborhood, regression tree, and the neural network. So you have to select a particular method and go for this one. So we'll see the methods one by one. So the first one is called as the multiple linear regression. So this multiple linear regression, this method is performed on the data set to predict the response variable based on the predictor variable, or used to study the relationship between a response and the predictor variable. For example, I'm having a student test score compared to the demographic information like income, education of parents, etc. So based on the we're going to have based on the income or education of the parents, your test score, it's going to have some compared with the comparison has been with the test score and the income of the parent or the education of the parent. So if the income of the parent is low and the education of the parent is low, still the test score is going to be above a range, then it is called as a good. Say for example, a student with the uneducated parent, he is scoring 50% of mark. That is good when compared to an educated parent kid having 80% of mark. It is taken as average because his parent is educated, so he will be expecting a better performance. So that is what it is based on the some other variable, that is the predictor variable. You are going to find the response variable value. Then the K nearest neighborhood. So like the classification method with the same like linear regression, this prediction method divides a training data set into groups of K observations using a Euclidean distance measuring to determine the similarity between the neighbors. So I'll be having the Euclidean distance. There is, say, for example, I'm having Euclidean distance is nothing but I'm going to have two variables, so X and Y. So I'll be going to find the difference, the mean value, the difference of this one. So X squared minus Y squared divided by 2. So that will be the thing. So like this, I'm going to find the Euclidean distance, and then these groups are used to predict the values of the response for each member of the validation set. And the third one is called as the regression tree. So a regression tree may be considered as the variant of decision tree designed to appropriate real valued functions instead of being used for classification methods. As with all regression techniques, Excel Miner assumes the existence of a single output variable and one or more input variables. The output variables is numerical. So the general regression tree building methodologies allow input variables to be a mixture of continuous and categorical variables. A decision tree is, we've already seen decision tree. A decision tree is generated when each decision node in the tree contains a set of contains a test on some input variable value. The terminal nodes of the tree contain the prediction output of the variable things. Then we'll see next one is called as the neural network methodology. Artificial neural networks are based on the operations and structures of the human brain. So it is artificial neural network is nothing but we have neurons, and based on the working of the neurons, we will be having our operations. So the same way, the system has to do it. So this is what is called as artificial neural networks. There will be these networks process one record at a time and learn by comparing their predictions with the record with the actual known value of the response value. So errors from the initial prediction of the first record are fed back into the network and used to modify the network algorithm the second time around. This continue for many iterations. So you are going to learn from the based on the prediction, you're going to get the outcome. So, and it will be comparing that with the actual outcome, and then you will be again trained that. So that is how, until or unless it is giving a higher accuracy, will be keep on training. And then we are going to have the prediction methods summary. So the training technique performed for the database either to predict the response variable based on the predicted variable or to study the relationship between the response variable and the predictor variable. So this is what we are going to have as prediction methods. And the Excel Miner is one tool which supports the use of 4 prediction methods. That is we have seen the multiple linear regression, k nearest neighbor regression, and neural networks. So all the 4 things are being predicted. And we are going to see the next topic of thing called as the accuracy. So how I'm going to classify, how I'm going to find the classification accuracy? There's a formula for that is the number of correctly classified test examples by the number of testing examples. So how I'm going to correctly identify, say for example, I told you in the starting of the presentation, I'm going to have a set of a bucket full of balls and it is of different colors. How I'm going to predict how there is totally, say for example, there are 100 balls in that. So how many of the balls I have classified it correctly as it's a red color, it is blue color. So that is being perfectly classified. That is the correctly classified one divided by the total number of, say for example, 50 balls has been classified correctly. So 50 divided by 100. So 0.5 is my accuracy. So this is how I'm going to find the accuracy. So what is mean by called as the good classification accuracy? So you cannot tell that having that higher thing is for all input variables, getting a higher value is not a good thing. So if I'm having a previously approach, say for example, the linear regression, if I'm having a data set, I'm going to get 0.5 as the accuracy. And if I'm going to use the k nearest neighborhood algorithm for classification and I'm getting 0.7, that is the better solution, better accuracy. So you cannot tell that only 0.99 is a better accuracy. So this, so you'll be having a question of data to a data miner. So he'll be measuring the quality of the data mining algorithm. So you can estimate how good your decision tree or a neural network algorithm are estimating the classification of the data. So that is what I've told you now. So we'll have some of the things like, so according to myself, an algorithm is well fitted to the problem when you get the classification accuracy above 97, for example. So it should have a higher accuracy, but only in the particular domain, if it is going to get that accuracy, then it is depend on the domain. So you can apply for other things. Okay, and you have to find out on the various domains, you have to fit and find out the accuracy performance. And you also have to understand this, that it is not going to have the application where you're working. So the currently application, we can work with some FintWeb project and we can find out whether it is going to have the accuracy good or not. So next we'll see about the ensemble methods and model section. So you'll go into selection. So we're going to have the ensemble method. What is mean by ensemble learning? It is nothing but it is going to combine several models. So I've told you, there are different models, classifier models. I'm going to combine all the models. So we have learned 4 models. So we have learned about the linear regression model. We have learned about the neural network model. We have learned about the K nearest neighborhood model. So making them all having into one thing, combining all these, it's called as the ensemble model. So the approach allows you to for production of better predictive performance when compared to a single model. So you can see here, I'm having a data set, dividing that data set into different categories. So different partitions. So data set one, so this given data set is divided into 4 partitions, and then it is being given into different classification algorithms, and combine the result of all the classification algorithms, you're going to get the this end result. And there are 3 problems that can be overcome by this particular ensemble one. So the statistical problem that arises when the hypothesis space is too large for the amount of available data. Hence, there are many hypotheses with the same accuracy on the data, and the learning algorithm chooses only one of them. So this is risky. So for the accuracy of the chosen hypothesis is low and unseen data. So based when the amount of data is too large, it is better to go for an ensemble model. And then the computational problem arises when the learning algorithm cannot guarantees the finding of the. So if I take only one particular algorithm, classification algorithm that may not provide the solution for the particular data set, then it will be a problem. And then representation problem. So it is not appropriate for that particular representation of that particular particular data set, then again it will not give you a thing. So when I take for more than one method, classification method and combine, I can go for the pros and cons of each one can be carried out by the other things. And there are 2 types of ensemble classification. So one is called as bagging, and one more is called as the random forest, which is an advanced of this bagging. So bagging is nothing but the bootstrap aggregation, which is used to reduce the variance of the decision tree. Suppose a set of D tuples, set D of D tuples, it is taken for each iteration. So Di of the tuple is sampled with replacement from D. So when I go for this, so multiple subsets are created from the original data set with equal tuples and selecting the observations based on the replacement. A base model is created for each of these subjects. Each model is learned in parallel for each training set and independent of each other. And the final prediction are determined by combining the predictions of each model. And the random forest is an extension of bagging. So each classifier in the ensemble is a decision tree classifier and is generated using a random selection of attributes at each node to determine the split. So during this classification, each tree votes the most popular classes returned. This is how it has been done. And implementation of random forest. So you're going to have multiple subsets are created from the original data set, selecting observations with replacement. A subset of feature is selected randomly, and whichever feature gives the best split is used to split the nodes iteratively. And the tree is grown to the largest. So it is keep on added, it is going to enhance and repeat the above steps and predictions is given based on the aggregation of predictions of n number of trees. This is how it is done. So we're going to have a glimpse of all the things what we have learned this particular last 1 hour. So it is a classification is the process of identifying which category of new observation belongs to based on class training data containing observations whose category membership is known. Prediction of is the process of identifying the missing or unavailable numerical data. Prediction method is performed on the data set to predict the response variables based on the predictor variable and are used to study the relationship between them, the response variable and the predictor variable. And classification, it is going to be a data mining function which are the designs items into a collection of target categories And the goal of classification is to accurately predict the target class or for each class of the data. Thank you everyone for attending this particular session. Thank you.